Now, if you plot a quadratic or any graph, the graph is going to turn. If it's a curve, it's going to turn. Now, these are known as a turning point. The rate of change of the y as with respect to x is 0 here, because y is not changing. Hence, this is known as the turning point. This is also known as stationary point. Then we got a point here as well. That's where it's turning as well. Now, these 2 points, the green ones, are known as the turning points, also known as a stationary point. Then we find the nature of this turning point by doing the second differential. Second differential will tell us what is the nature of this turning point. Is that a maxima or that's a minima? Well, maxima is the maximum point of the curve where it tries to turn. And the minima is the minimum point where it tries to turn. Okay. Now, let's have a look at the next one. Now, let's say we got these questions. I'm just going to do few and then you can just do the other one on your own. So, let's have a look at the F. And let's look at the I. So, let's have a look at these two. Now, find the coordinates of any stationary point on each curve. Now, to find the coordinates, let me just get to the next one. 1 second. So, let's say if I want to find the turning point of the top one, the stationary one, F. Let's try to do the F first. Okay. Now, let's say we got an equation y equal x cubed minus a 9x squared minus 21x plus 11. Now, first I need to differentiate. Now, when you differentiate, make sure you do all the steps. I am going to skip the step, but you have to do all the steps. X cubed minus a 9x squared minus 21x plus 11. Now, when you differentiate this bit, you will get, when you differentiate x cubed, that will give you 3x squared minus the 9 is already there, so that becomes 9 times 2 because the 2 comes out as well, 18. 18 and reduce the power of x by 1, so 2 minus 1 is 1. And the differential of minus 21x is minus 21. If you're not sure how I got these values, have a look at the previous videos. Now, this is actually a dy over dx. This is dy of dx. You need to remember to find the turning point. Turning point is a point where the dy over dx is 0. So we go to the next slide. We have a look at, we will put, let me just write here for turning point. For turning point, dy over dx has to be 0. So I'm just going to put this thing, 3x squared minus 18x minus 21 equals 0. So 3x squared minus 18x, was it minus 21? Minus 21. Minus 21 equals 0. The first thing I can do is, can I simplify that one? Yes, I can, because I can divide the whole equation by 3. Just take the 3 common. X squared minus a 6x minus a 7 equal 0. Which means I can move the 3 on the other side. So 0 divided by 3, it's a 0. So I got x squared minus 6x minus 7 is 0. You can solve it by using either a quadratic formula or you can just factorize it. If you don't know how to factorize, have a look at the factorization video. Now, or you can use a quadratic formula. Okay, if I factorize, what will actually happen, the way you do factorize, let me do the factorization video on the next one, so just in case. X squared, I'm just going to go on next page. This is factorization. X squared minus 6x minus 7 equals 0. For the factorization, what you do is you multiply this minus 7 with that one here. So minus 7 times x is minus 7x squared. Then you need to think of two numbers. When you multiply, the answer is minus 7, but you add, the answer is minus 6. So minus 7 multiplied by 1. The answer, if you multiply, the answer is minus 7. When you add, the answer is minus 6. So you just do x squared minus 7 here. Instead of minus 6, you're putting minus 7x plus 1x. Yeah, that's how you do, because they're still the same. Now here, take the x common. If you take the x common, you're left with x minus 7, because they were x squared, so still the x. Here, you take 1 common, and you're left with x minus 7. You see this x minus 7, this x minus 7 is same, which means you're doing right. So you write x minus 7, the one that's in bracket, just once, and then you copy the x and the plus 1 from here. Equals 0. Going back, so that's how we factorization done. Going back, now factorization of that one is x minus 7. So I'm just copying that thing from here, and x plus 1. Now we got this bit. Now what you need to do is we need to find the turning point of the curve. So we need to put that equal to 0. So you write down x minus 1 x plus 1 equals 0. That will give you x equals how much? Minus 1. Then you also do x minus 7 equals 0, which will give you x equals a 7. So now we got the x coordinate of the turning point. We do not have the y coordinates. To get the y coordinates, you need to go back and put in the real equation. What is the real equation? The real equation is this: x cubed minus 9x squared minus 21x plus 11. So to find the y coordinate, you got y equals x cubed minus 9x squared minus 21x plus 11. Now what you need to do is you need to put, instead of x, you need to put minus 1. So you got minus 1 cube minus 9 times minus 1 square minus 21 times minus 1 plus 11. When you put x equals minus 1, you got the answer 22. Now you need to put x equals 7 to find the other turning point. Exactly same. So not 3 cube, 7 cube minus 9 times 7 square minus 21 times 7 plus 11. And that will give you another answer. Which means when x was minus 1, the y was 22. So the coordinate is minus 1, 22. That's one coordinate of turning point. Then the other coordinate of turning point is when x is 7, the y was minus 234. Yeah. So the coordinate is 7, 234. We can check this coordinate by plotting equation of this graph. Now when I plotted the equation of the curve, this is how the curve is going to look like. It's zoomed in quite a lot. So this is the one turning point. If I click on that one, that's the minus 122. So that turning point is correct. And if I go all the way down, that's another turning point. So that turning point is 7, minus 234. So we got the right turning points. Thing is nature of the turning point of the curve. One of the turning point is maxima and one of the turning point is minima. We already know which one is maxima because we have seen the graph, but let's say we don't know, we haven't plotted the graph. and we need to find the turning point. So what we'll do is we will get the dy over dx, first differential. We already got the dy over dx, and that is equal. We got the first differential. That gives you the turning point. To nature of the turning point, we need to do second differential. So differentiate that again. When you differentiate that again, that will become a d square y over dx square. And you need to, obviously, you need to do all the steps. So here, when you differentiate on this side, that becomes a 3x square minus 18x minus 21. So let's differentiate this thing. When you, obviously, I'm skipping steps. You need to do all the steps. So you need to put a differentiation here, here, and here, and then differentiate. So that will become a 6x minus 18, and differentiation of that one is just a 0. Now, I got the value, and this is my second differential, d square y over dx square. I got this bit. I need to find the turning point. What kind of turning point is that? Is that a maxima or a minima? To do that one, what I'm going to do is I need to put the 2 points. Okay, now I got the second differential, and these are the points. In the point, the only one that I'm concerned is the x, because here the only thing I got the x. So I'm just going to do that. First, I'm going to check this point. To check this point, what I'm going to do is in here, I am going to put the point, that point. So when x is minus 1, that's an x, by the way, x is minus 1. So 6 times minus 1 minus 18. And that will give me a d square y over dx square. And that value will be how much? Yep. We don't care about the value of that one. We just look at if it's a positive or negative. It is a negative. When the second differential is negative, it means this is a maxima. This is the main thing, as the value of the second differential is negative, so it is the maxima. We don't look at the number, we just look at if the value is positive or negative. Now then what we're going to do is we need to test the second one. And now to test the second one, let's have a look. Let's change the color to red. So we go back, use the same equation, and now this time we're doing that one. So d square, second differential, equals 6x minus 18. Instead of x, I'm going to put this value. When x is when x is 7. So you put that value here. 6 times 7 minus 18. As a coincidence, the answer we got is a positive 24. It can be any other number. You know, it's just coincidence that one is positive, same value, but different sign. Now here you can write down as the value of the second differential is positive, so it is the minima. So this value, this point is going to be the minima point, and this point is the maxima point, which means when you draw a curve, this point is going to be on the top, that's the maxima, and this point is the minima. Yeah, so that's how we figure out which one is minima and which one is maxima.